Okay, welcome to 2.6. Hopefully you're able to reduce your radicals, simplify your radicals like a boss, and now we can do the next thing with them. Remember when you first learned about polynomials and adding together like terms? You would have been taught that you needed to have the same variable for like term and the same exponent. And if those two things were the same, you'd be able to collect your like terms together. Like let's say they were being added together, and these two together would be a 4x squared. Well, this concept applies to radicals as well, where when we add and subtract radicals, the golden rule for it is to only combine like radicals, okay? They have to be like radicals. So what is a like radical? You have to have the same radicand, so the number that, or our expression that's under the root sign, and the same index. Okay, so it's very similar. So let's do a couple of examples here. I'm going to do number 1. We're going to combine these radicals together. So the very first thing that we have to do is we have to always simplify first. So simplify radicals. And, you might be able to start on a different first step, but, generally speaking in math, if we make something more simple before the next step is easier to do, okay? We just keep simplifying. Once we do this simplification step, we might have to perform an operation. Maybe not, well, in this case, the operation would be adding. In this case, you have to go with BEDMAS. You might be adding and subtracting within the brackets, and then you're going to multiply the 2 in, okay? And again, there's nothing stopping you from multiplying the 2 in first using distributive law, but I think it's just my preference to always simplify and use BEDMAS first. So, but whatever floats your boat, as long as you don't make mistakes, you're fine. Once you perform your operation, you need to collect like radicals. Okay, so let's do it. I have some factor trees on the side already written for the first one, and we'll do number 4. So number 1, we're going to simplify the radicals that are there. So number 1, this is going to equal to, over here, my perfect square is 4, and the non-perfect square is 7. So we're going to turn it into baby radicals. And root 28 is equal to root 4 times root 7. Here, let me just write it over here. And then plus root 175. It has a perfect square of 25 times 7. So let's break it down into the baby radicals. Now let's simplify our perfect squares. If you wanted to go straight from a root 4 to root 2 without writing root 4, go for it. Okay, root 25 is 5. And grab your highlighter, hopefully you have one, and you can see here that these are like radicals. So if I was to go into a parallel universe here, if I said, hey folks, what is 2x plus 5x? You're going to say 7x. Okay, this is the same concept here. I have 2 root 7s plus 5 root 7s. So altogether, I'm going to have 7 root 7s. Awesome. It's a lot of 7s. Okay. When you're in a test, feel free to do a decimal check. Put this into your calculator, put the question in, and then put your answer into the calculator. These decimals must match, okay? Do a decimal check. It's one thing to get a question wrong on a test when you don't know what you're doing, but if you do know what you're doing, do your checks. It just takes a second to do it. Okay. Number 4, and I will give some time to number 3. What I would be tempted to do on this one is just simplify everything inside the brackets. Follow BEDMAS, okay? And then collect any radicals that you can, and then at the very end bring in your -3. It's not that you can't start with the -3, but I think just generally speaking, follow your BEDMAS. It's a good roadmap. Okay, number 4. So I'm gonna do that. I'm going to leave the 1/4 out front. Okay, it's not hurting anybody. And now with the root 75, I have it on the side here. It's gonna be root 25 times 3. So I'm gonna turn my root 25 straight away into a 5. And then I'm gonna have my non-radical right beside it. Minus 4, let's put the 4 in there, times root 12. So come over here, I'm going to square root the perfect square of 2 and leave behind the 3. Okay, and since these are notes, let's do some color. So we've got common radicals, like radicals. What do I have here? 3 times 5, this is a 15. And 4 times 2, this is an 8, just to use the same line there. And now let's actually, because they're common, let's collect them. So what's 15 root 3's minus 8 root 3's? Altogether, looks like I'm going to have 7 root 3's. And by simplifying up in the brackets, it's just melted away into this nice little fraction here. And now we just multiply our constants together, and we get 7/4 root 3. That's our final answer. Okay, not so bad. Now, stepping it up, we can get this a little bit uglier, but not much. I think this one's looking fairly straightforward. We're starting to get a little bit weird down here, so I'll do 2 and 3 right now for you. Okay, simplify your radicals first. There's nothing that we can do with the 1/3, so just leave the 1/3 alone. But 81, this is 9 times 9. So let's take the square root of that, and maybe I'll show it here. This is going to be, this is going to equal to the root of 81 times the root of x, right? I can take root 81x and baby radical it. And let's see what I can do over here. Minus 1/2, just letting that hang out. It doesn't look like I can do anything with this. This is pretty simplified. Okay, so I'm just going to rewrite it. My pen just is not having a good time today. I think my computer's tired. Okay, let's keep going. 1/3 times 9 root x minus, I'm going to actually distribute the 1/2 at this point. So root x divided by 2. Remember, there's an invisible 1 there, so just multiply the denominators together to get 2. 1 times root x is root x. A negative and a positive is a negative and a negative is a positive. 1 times 6 is 6. There's an invisible 1. 2 times 1 is 2. Okay, let's write on this question. Just take that to a 3 right away. Save us writing a line. And then let's cancel this. What's 9 divided by 3, you guys? That's just a big 3. So let's turn this into a 3 root x minus a root x over 2 plus 3. Now we have a situation in which we only have 2 like radicals. This 3 does not get to be mushed into anything else, but we can combine these two. We're going to need to get common denominators though, because right now this is a 1/2. So let's turn this into an over 2, and then we're going to multiply this by 2, right? 2 divided by 2 is 1. So I'm not changing this by writing 2 over 2 right now. But what that does is it gets us common denominators. Super important to put your fraction hats on, you guys. So this is 6 root x over 2 minus root x over 2 plus 3. Almost done. Put it over one denominator. There's an invisible 1 here, so let's put it in there. 6 minus 1 is 5 root x. Again, what's going on in the top, in the numerators? Like just this blue zone, okay? In this blue zone, it would be the equivalent, if I, let's come over here for a second. Okay, come on. If I do this in the blue zone, if I did, what's 6x minus x? You would, of course, say just 5x. This is no different. Just pop in, let's see, pop in root x is that, root x, and root x, and root x. I guess I could have just rooted it on top. Okay, don't forget about the plus 3. Don't lose any of your little children here. You are responsible for keeping track of every one of these little guys. Okay? Okay, last question, and this is the end of the lesson today. It's a super short lesson. 3. What do I do with all this mess? Well, I looked at it and I'm like, oh man, this is gross. But this root b squared, geez, let's simplify that sucker. Let's turn that into a b right away. So I'm going to just keep this root b all by itself and just turn that other b, like root b squared is just b plus 2. And then minus root b. All right, so now that we've simplified inside the brackets, let's distribute in. This is b root b, just push them together, plus 2 root b. Notice that whether you're a variable or a number, when we're multiplying this in, it's just like saying, what is x times 4? Well, you write it as 4x. So if I have a root b times a b, you're just going to write it as b root b. Okay? So there is a multiplying section coming up. So this one's a little bit premature because we will do a lesson on it in 2.7. But anyway, you can handle it. It's not too big of a jump, I don't think. Oh my gosh, I almost forgot about minus root b at the end. Oh, look at that. Let's use pink. We've got 3 like radicals. So all you have to do is combine the coefficients together. There's an invisible 1 here. But here's the thing. Oh, this is interesting. We can combine the 2 with the negative 1, but we can't combine it with this b. That is, you can't combine constants with a b. If this was a number, you could combine it with these numbers, but I think we have to just leave this guy on its own and then just write 2 minus 1 is 1. If you don't write it, that's fine. Root b. And I don't have the answer handy here, but I don't know. This is box worthy. The answer might have had the root b's on the outside though. See, there's a common factor of root b here. So let's pull out the common factor and just leave behind this. Ooh, I like the look of this better. That's tight. I like the bottom one. I don't know. They're both pretty darn good though. But this just looks cleaner. Like that GCF of root b when it just doesn't come out. So this would this is what makes me happier. Anyway, good luck you guys. Have a great weekend and I'll see you when I see you. Stay safe.